This is the first video in a 3-video series where I'm going to talk about the map raster operation, the first part of the project. Now, these videos are totally optional. I'm just putting them out there for those of you who like this style of delivery a little more, so it's redundant with the spec. There's nothing here that the spec won't tell you, but if you'd like, here's an alternate way of looking at the problem you're going to be trying to solve. So everything I'm going to talk about in these videos is in these Project 2C slides that you might find it helpful to step through. And these will be available on the spec. In fact, they're linked there. Now, one thing is, I looked at the video that 1 year younger me made when he also didn't have a cold, and I thought the video was pretty good. So I'm actually going to let me from a year ago explain this, though I will note that something changed in the project. So this semester, the method that you're going to write to actually provide images is called process request, and it is part of the Raster API handler function. So I am going to kick it off, or let me from a year ago take over, but be aware that whenever he says get map raster, he's talking about what we call process request. Okay, so that's it, and yeah, take it away, me.
One of the hardest things in this entire project is just getting started on this first part, rastering. So the rastering part of the assignment, the user is going to use their web browser and request a certain region of the world, and that's going to be passed as an argument to your function getMapRaster. That is, their request will be passed as an argument of it's a map from string to doubles. We'll talk about that in a moment. And then your function is supposed to return a map that goes from string to object that will supply all of the information needed for the web browser to be able to display the appropriate images. Okay, so it'll become clear as we step through in a little more detail. So let's get a sense of what these params are all about. And we can do that by running our code with this print statement uncommented. And now, after everything starts up, we can create a new, I think I have one actually already open maybe. Okay, localhost 4567. So when we open up map.html now and go back to IntelliJ, we see that this print statement has printed something out. And in particular, it's printing out the request that the user is making. And so if I do something like rescale the window, we can see a bunch of new requests are sent, now with different widths and heights. If I go really narrow, we can see the width field gets smaller and smaller, and we can make it larger. And so your code's supposed to be able to handle all of that. Now, one thing I'm going to encourage you to do when you're first starting the project is don't use map.html. Instead, you should use one of these 3 files that we provided that have a hard-coded query that your program is supposed to handle. So if I do open in browser, this file, then I see that only one request is made here. So it's a new request. You didn't actually see it show up probably, but it has width 892, height 875, LR lon -122, 24053, all this stuff. Exactly what it says on this page. And if I resize this one, nothing happens, right? This is not interactive. You can't do anything. But it's a simpler query. As you can imagine, it's just easier to debug when you don't have to worry about things changing. Okay? Now, what's nice about with these hard-coded files is it also provides the exact result we expect. So this is the map from string to object that we expect. So in other words, when we said this is the query results, right here on the page is exactly what's expected, which also makes it easier to analyze and debug the performance and behavior of your code. The HTML file here will also display the output of your program, which is generated from this here. And in this case, since we haven't actually done anything, it says you haven't implemented getMapRaster, so nothing is displayed in your browser. That's what we mean here. This image is not showing up, but ultimately it should display an image looking awfully like this. And so let's go through this example in some more detail. So let's talk about the specific request that is provided in test HTML. So we have ULLon, and we have ULLat, LRLon, LLat, W, and H. UL refers to upper left, and LR lower right. Actually, I'm going to interrupt myself very quickly to say, be aware that you do not need to watch this video. So if you're somebody who doesn't want to watch this, everything is in the spec. This is just as an alternate way of thinking about everything. I find it handy sometimes, to have a video. Ooh, spooky, lots of me. Anyway, so I find it handy to have videos occasionally, and maybe you do too. Anyway, but if you don't like videos, you can stop watching. You won't miss anything. So the upper left longitude and upper left latitude, that refers to the top left corner of the world that the user wants to see. So for example, looking back at our HTML file, geez, I got a lot of stuff open here. Let's get rid of those. If I go back to this, that means it's something close to this top left corner, and the LR lat and LR lon refer to this bottom right. And latitude is our y coordinate. Oh, it's me again. Get out of here, me. So this lat is the y coordinate, and lon is the x coordinate. Okay. And so what we could do is actually use Google Maps to see where these places are. So if we go to ULL lon, and I go to ULL lat, this should be the top left corner of the world that I want to display. Now, if I do it in Google Maps, if you try it, be warned that the usual convention is actually y coordinate first. That's just how it is. So this is a region of the world that the user wants to see, a box with this in the top left corner. Now, I found it more instructive, instead of just using regular Google Maps, to use My Maps. And let's do this exact thing again and get a sense of what exactly this query is all about. So if I go to Bearmaps example, okay, so if I search in My Maps, I can now go through, and I'm going to set up a pen here. This is not something you need to do, but I find it helpful to understand what's going on in this video. So this is the upper left corner of the query. And then we can also search for the lower right corner of the query. So I'm going to do LR lat, LR lon, and this is the bottom right corner, or lower right. Okay, so lower right corner. LR corner. Okay, so this is the query box that the user was asking to see. I'm actually also going to add a little shape here so we can actually visualize it a little better. This is not perfect, but good enough. And so this is the query box that the user wants to see. And you know what? Let's make it purple, if it'll let me, to match the figures we'll have. Okay. Oh, come on. Purple sounds cool. All right, there you go. So this is the region of the world that the user wants to see. And so your job is to display this. And we'll talk about how you do that in the coming minutes here. Okay, so what the user is asking is to see that box that we just showed. And furthermore, they want it to be displayed in the browser in an 892 pixel wide by 875 pixel tall image. That's what they're requesting. Okay. So to understand how we're going to do this, let's talk just a little bit more about another really important, another really important concept that you'll need in order to display things. So the first concept is understanding what region of the world the user wants. This next one is about the level of zoom that the user wants. So at our latitude, at 38 degrees north, each degree of longitude, 1 degree here, is about 288,200 feet. In other words, if we went from 120 to 121 longitude, that would be 288,200 feet. Now, what we could do in order to convert from a width in longitude to a width in feet is just multiply by this constant, and we find that the user wants a box which is ultimately 317 feet wide, and we can measure that, and it's going to be slightly off because I didn't do a perfect drawing. But if I measure this, you can see, okay, it's close. This is 317 feet. So the width of the world the user wants to see is in the order of a few hundred feet. And the user also wants it to be drawn in a space which is 892 pixels wide. So ultimately what the user is requesting is an image that has a certain level of sharpness, a certain level of zoom. In particular, they want 317 feet covered in around 892 pixels. So 317 feet divided by 892 pixels is 0.355 feet per pixel. So in other words, if I'm moving my mouse 1 pixel, I want that to represent about 0.355 feet. That's the level of zoom. Now this is really important because technically, if you don't take into account zoom, you could just zoom out all the way and you could say, well, technically this includes the entire region that the world wants, or that the user wants, but obviously that's not going to cut it. And really what we care about also is the resolution. Okay. So to bring that all together, ultimately what our user wants to see is some region of the world, roughly like so. And I've outlined it as a dotted purple box. See? And there's two critical requirements that your program is going to need to achieve. The first is you need to draw the entire query box, but it's okay if you end up with a little extra stuff, because what the web browser will do is only display the part that matters. So the user wants to see this, and we want to display at least all of this region. And the second thing is, in addition to getting total coverage, we also need to make sure that we have enough pixels per distance in what we call lon DPP. What's lon DPP? Well, that's just this here, 0.355 feet per pixel. And you can either conceptualize it in feet per pixel or you can think of it as longitude units per pixel. Either way, up to you. Okay, or sorry, longitude units per pixel. So you can think of it as 1.23542 times 10 to the minus 6 longitude units per pixel, or I like to think of it in terms of feet because I actually know what those are. Okay, so that's it in terms of the basic picture of what the user wants and what you're supplying. So in the next video, we'll talk a little bit more about the mechanics and input data that your program is going to use.